Hello students, so we were solving question 4. Okay, let's solve question 5. Draw appropriate Venn diagrams for each of the following. Okay, so first one is A union B, the whole complement. Okay, so first you have to draw A union B. So this is our universal set U. Okay, A is there, B is there. So A union B is this whole thing, right? So you are removing A union B complement is what? You are removing A union B from the whole set U. Okay, so you are removing this, so you will get this thing, and this is your set A union B complement. Now second one, they have given A complement intersection B complement. A complement intersection B complement. Now if you see De Morgan laws, okay, this itself is your A complement intersection B complement. So this is the same thing. This diagram applies for the second one also. Okay, you are removing A, also you are removing B, so its complement, its intersection, okay, will be this the space which is there in U, left out space. Okay, then third one is A intersection B, A intersection B complement. Now again you have to draw first A intersection B. This is universal set. A and B is there, and its intersection is this, A intersection B. Now you are removing this part, so you'll get this whole thing which is A intersection B, the whole complement. Okay, now according to De Morgan, this is same as A complement union B complement, which is our fourth question. Okay, A complement union B complement. So for this also we are going to draw the same thing. Okay, now next is let U be the set of all triangles in a plane. So set of all triangles. Now many triangles are there: scalene triangle, right angle triangle, then acute angle triangle, equilateral triangle, isosceles triangles, right? If A is the set of all triangles with at least one angle different from 60, what is A complement? So A is the set of all angles which are different from 60. So it can be a right angle triangle, it can be a scalene triangle, it can be a say angle triangle with angle which is not 60. So a A complement will be a triangle with angle 60, right? So angle 60, all angle 60 degree is which triangle? Equilateral triangle, right? Equilateral triangle in which all angles and all sides are equal. Then we have isosceles. In isosceles, any two sides are equal, okay, and its corresponding angles are also equal. Okay, so A complement is the set of all triangles which are equilateral. Okay. And last one is fill in the blanks to make each of the following a true statement. Okay, A union A complement. A union A complement. Now A set is there and A complement means the things which are not there in A. If you draw this is your universal set, okay, and this set A is there, and this outside you will get all the A complement. Okay, so A complement together with A you will get the whole set, which is universal set, right? Then second one is null set, its complement and A. Okay, null set means nothing is there, and its complement will be everything is there. So its complement is U, universal set. Okay, and universal set intersection with A common is what? A set. Okay, then third one is A intersection A complement. Okay, so A and A complement, nothing is common, so it's null set. Okay, third one is U complement intersection A. U complement means the whole set, universal set is not there, it's complement, you are removing the whole set. Its intersection with A will be what? So null set, right? Nothing is there. Next is we'll start with the new subtopic, that is practical problems on union and intersection of two sets. Okay, so if you have say two sets A and B which are finite, okay, then number of elements in A union B is given by number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay, now if the thing is there is nothing common between A and B, A intersection B is empty. Okay, then you can take this number of elements in A intersection B 0. So if this is the thing, then you can write number of elements in A union B is equal to number of elements in A plus number of elements in B. Okay, same thing goes for three sets. Okay, now so three sets are there, A, B and C. Then you have number of elements of A union B union C, okay, is equal to number of elements in A plus number of elements in B plus number of elements in C, okay, minus number of elements in A intersection B minus number of elements in A intersection C minus number of elements in B intersection C. Okay, and plus number of elements in A intersection B intersection C. All three you have to take. Okay, let's solve one example which is given in the textbook, example 23. If x and y are two sets such that x union y, so number of elements in x union y is given, that is 50. Okay, and x has 28 elements, so number of elements in x is 28 and number of elements in y is 32. Okay, so how many elements does x intersection y have? So you have to use that formula. Okay, so number of elements in x union y is equal to number of elements in x plus number of elements in y minus number of elements in x intersection y. Okay, so this is 50, this is 28 plus 32 minus intersection y. Okay, 60, so you have to take it here. Okay, so I'll write it 50 minus 60, so this is minus 10, so 10 is the number of elements in x intersection y. Okay, so here you will be introduced to some practical problems. Okay, Next is example 24. In a school there are 20 teachers who teach mathematics or physics. So here you have to decode the language. Okay, or means, or is union. Okay, and if it is given, then you have to take intersection. Okay, so of this 12 teach mathematics and 4 teach both physics and maths. Okay, here now it is given and, so this is intersection. So there are two things, that is mathematics and physics. So number of teachers which teach both, means or is given now, mathematics or physics is 20 and 12 teach mathematics, so number of mathematics is 12, and here both physics and mathematics 4 are there, so intersection is 4. Okay, you have to find number of teachers who teach physics. So this is NP you have to find. So same way you have to solve. Okay, I'll directly write formula. So this is 8. So 20 minus 8. So your answer is 12. Okay, let's solve next one. So in a class of 35 students, so total 35 students are there. 24 like to play cricket, 16 like to play football. So one thing is cricket, other thing is football. Now also each student like to play at least one of the following games. Okay, so how many students like to play both cricket and football? So here both is given and is given, right? So and means this is intersection you have to find, and what is given is union. That is here it is written each student likes to play at least one of the two games. Okay, at least one of the two games means this is your union. So let's write. And already it is a class of 35 students, right? So its union is given. They have taken x and y, so union is 35, x is 24, y is 16, and you have to find intersection y. Okay, so I'll write here directly 35, and this you have to add, right? 40 minus 40 minus, so this is 5. This is easy. Okay, so 5 students like to play both the games.